it seems to be the nature of all of our stormwater research projects. Inevitably, as soon as they kick off, we end up in a drought. And it's happened at least once before on a different project. All we can really do, and what we have done, is extend the sampling phase of the project and hope we'll get some rain. The original motivation was a rule that EPA published and they had finalized that set a 280 NTU, nephelometric turbidity unit, which is a measure of water quality, set a 280 limit on the turbidity and runoff coming off of our construction sites. The fundamental problem with establishing a numeric limit for construction sites is that construction sites are hugely variable across the nation, across different spectrums of industry. Different types of construction have different issues with their runoff. Linear projects are different from box construction. Not to mention huge variations in, take soil type, in rainfall intensity and rainfall patterns, in the stage of construction. You know, in a certain stage of construction you could expect a certain turbidity, in another stage of construction you might expect something completely different. The biggest misunderstanding was thinking that compliance with the CGP is all about your silt fence and rock berm. In fact, it should be about your erosion control. That's really the key element. What we're focusing on are the sediment controls, the silt fence and the rock berm, and those have a removal efficiency all over the board, but if it gets higher than 40%, I would be shocked. And a lot of times they're misinstalled and they actually increase erosion. Flocculants, when they finalized the 280 limit, they were basing it on what they perceived to be the removal efficiency of a suite of BMPs that are typically used. But they included the use of flocculants. We don't use flocculants, and they're really not used much in Texas at all. It's a safe assumption that when they go back to the drawing board, they're still going to assume that flocculants are a viable pollutant control technology, and that's going to lower the limit. They're going to propose a lower limit because they're assuming the permittees are using flocculant. Which means now we've got to figure out how and if we can use flocculants. There's a gazillion types. Some of them work only on certain soil types. Some of them are expensive. There's safety issues with some of them. That's another arm of this research project is looking at flocculants and whether or not they're feasible and how they work and how we would set up like specifying them, that sort of thing. Or my concern is that no numeric limit is going to really be feasible, possible to meet in all circumstances. The other problem is that EPA based that original 280 on a very small sampling of construction sites. Very few linear projects, and none that I'm aware of from Texas, which actually leads to one of the main goals of this research project, is to gather data on linear projects in Texas that we can use with EPA. We can give that data to EPA and they'll use it when they recalculate the limit. So hopefully we'll end up with a regulation that can actually be complied with.